Hi everyone, we are group 6 and my name is Yingnan, and here is all of my group members. The topic of our project is survey on MGWR. We will start our presentation with the introduction of geographically weighted regression with GWR and multi-scale geographically weighted regression, it is MGWR. Then we'll cover the applications for such regression, including various disciplines where it can be applied to, how we can categorize them based on convergence standard, the measure of performance, and data processing. Finally, we end our presentations with other relevant methods. So first part is a brief introduction about these models dealing with geographical data. One of the most common used model is ordinary least squares, which is also called OLS model. Geographically weighted regression model is proposed based on summarizing the local regression analysis and variable parameter research and drawing on idea of local smooth. The formula is shown as below. Yi is the response variable. Beta I is the J's coefficient corresponding to the location. Each xij is the J's predictor variable and has specific data. This will be in the form of a matrix of calibrate the model instead of producing a global estimate of each relationship in the model. It allows the relationships between the response variable and predictor variables to vary spatially. However, GWR approach constrains the local relationships within each model to the same spatial scale for all of the process in the model. In that case, multi-scale geographical weighted regression is introduced. It allows the conditional relationship between the response and each predictor variable to vary at different spatial scales, and bandwidth is one of the most important results from this approach in the project. However, it uses the bandwidth instead of beta j, which indicate how the different relationships operate across different spatial scales, including global, local, and regional relationships. So bandwidth is the key to control the operational scales in MGWR. The second part is the applications where researchers choose GWR or MGWR and analyze the data. MGWR can be applied to a number of disciplines to determine the most decisive factor of a phenomenon. By considering weights for different geographic locations, here we have compiled a list of papers related to landscape, vegetation, and climate change, analysis of business location and price, public health, estimation of population, and even crime and mortality rate. And the following section is our refined taxonomy. We have classified our literatures into these categories, like that. And this is a table of the classification of convergence standard. We divide our articles into 3 parts, SOCF and others. And there are 3 ways to measure the performance of MGWR. The first way is called coefficient of determination, or R squared. It is to calculate the proportion of the variance in the dependent variable that is predictable from the independent variable. It can be used to test the hypothesis, and it tells us how well observed outcome can be replicated by the model. It defined as 1 minus sum of square of residentials over the total sum of square. Well, the first sum of square is obtained by the summing up the square difference of the observed values subtracted by the mean, and the latter is his sum of the squares of residentials, which is exactly the second criterion but with different notation. As for archaic information criterion, it is based on information theory, which measures the goodness of fit. It's defined as 2 times the number of parameters, denoted by k minus the logarithm of maximum of the likelihood function. However, if the sample size is small, AIC may select a model with too many parameters, causing overfitting. To address this, an extra penalty term for the number of parameters is added to the model, called AIC corrected or AICC. And here denote the same size as n approximates the infinity. That extra penalty term converts to 0 and AICC converts to AIC. And this is a table of our classification of measurement. This is the classification of data processing. Utilizing reverse nearest neighbor (RNN) strategy can handle frequently updated data on given location more efficiently. The performance of the proposed RNN GWR approach is compared with the performance of a naive GWR and fast GWR approaches. Experimental evaluation shows that RNN GWR approach is computationally efficient than the other approaches on handling frequent update data. And this is a reference. Okay, that's all of our presentation. Thank you for your watching.